So welcome everyone. Today we will talk about sort of like a big general topic, or actually three things, and things you sort of already kind of course have come across: names, scopes, and bindings. So things which are common with all programming languages, issues. So sometimes they're sort of obvious, but of course sometimes there are some, how should I say, ambiguities or nuances, meaning some things are not so clear. And depending on the language, things can be very, very different. So what I'll do is, of course, we have the slides. We actually have two different slides here at Ortus. You can use either ones. The official ones from a couple of years ago from a different instructor are here. But also, I see we don't have a notebook. So let's see if we can make a notebook and make these things a little bit more interesting about a relatively dry topic. So you guys, of course, now should be pretty up. We have the idea of closure, how closure does things, right? So we'll go over again how this general topic is across pretty much most languages. All right. So let's see here. Do I have a notebook on this? I don't think I have a notebook on this. Let's see. Name. Oh no, actually I do have a notebook. Okay, let's see. That's actually good. Good news, actually. If you do have a notebook, I'll be able to add things to this notebook. Let's see. Add the kernel. Python provides some pretty good ground for this, but I see that my notebook needs some help. Here. You'll be able to help me. So what's a name, basically? Name. Rose. Any other name is Rose, right? So basically, it's an identifier, right? You refer to what? To variables, functions, classes, modules, pretty much anything, right? So most languages, of course, these identifiers have specific way of writing, right? So let me see if I can make this a markdown. So names, right? Well, let's see if I can add on. Let the call complete, enable complete for markdown, right? So names in programming languages are identifiers, variables, functions, class, right? So when you assign something, the fancy word is binding. You bind something. Name is bound to some value, right? This value could be a memory address, could be actual value, like a numerical value. Well, again, a string value, of course, underneath there is a numeric value always, right? There's usually it's of course numeric value. And again, we all do it. Why? Because of course it makes things easier. So what are common restrictions for naming? What's the usual constraint? Most languages follow this.
Keywords, you cannot use keywords.
Yeah, you cannot use keywords. So what can you use for names? What's usual? I'm trying to see which languages don't have this, but basically what can you use? You have to start with uppercase or lowercase alphanumerics, right?
Yeah.
That's basically it, right? And then of course you cannot have spaces, right? Some languages, so-called example closure, has a dash is allowed, right? In many languages, dash is not allowed, right? Because that's minus, right? So, for example, underscore, right? Things like that. So how about dollar sign, right? Is dollar sign allowed? Depends on language, right? So some special characters, like for example, in a dollar sign is famously used in JavaScript, for example. Many libraries use this. It's like a, like jQuery in JavaScript library uses, a dollar sign because it's just a name, right? So usual naming conventions. Most languages have, right. So let's say Python, descriptive meaning, of course, that's like obvious, right? So underscore, right? Yeah, should not start with number. They cannot, not should, but cannot start, right? Cannot, right? There's things different in should, right? What's a good idea, right? You should eat your fruits and vegetables every day, but instead you eat just a cheese pizza, right, and ketchup, right, and that does not count as a vegetable, right? So depends on the country, right? So what else? Depends on. So this is right. Note the above convention. Some languages let you use special characters and names. For example, in closure, right? For example, in Clojure, it is customary to use in names, right? Not possible, not possible, not possible, not possible in Python, right? So yeah, Clojure. All right. So yeah. So we know, right? So what's another thing is which we have to be careful with naming. What's the word? Overloading, right? Meaning, yeah. Or also shadowing, aliasing, also, right? So same name, right? Could refer to multiple entities, actually, right? So, right. So overloading, aliasing, and shadowing, right? So we can do things like, right? In Python you cannot overload finance, right? So if you define, right, same name, right, you can't, right? Aliasing, right, you can, right? Shadowing, of course, this is, we'll see some examples later, right, when we will go some examples. Okay, so now let's see. Let's see. Okay, so examples, right? So obviously, right? I mean, it's just a stupid example, but of course, right? Let's do a really so. Example of name would be variable assign, variable. You know, my name bound to some string literal. Right, so my name, right, is Valdis, of course, right? So obviously, so now my name for the time being is bound string Valdis, right? Obviously, right? So that's the easiest thing, of course, right? So so we bound, right? Binding, right? So this is binding, binding. Right? Yeah, right. So all right. So, but there are different binding times. Now we come to start things get a little dicey. Binding times, right? So let's think about when can we bind things, right? In Python, well, when is my name becomes Valdis, right? When is my name bound to Valdis, right? Well, when you run this, right? So at runtime, right? So this is done at runtime. The above is done when we run code that is at runtime. Right? So that's one of the I would say the last thing. I mean, I don't think you can think of anything later than that, right? I mean, you run it. I mean, at some point you have to. Okay, yeah, my name is Valdis, right? Okay, but can you do what? How early can you do it, right? So that's sort of like theory. We get into sort of theory craft, right? So bind times. So what's the earliest we can? What's it? Static binding, right? So it would be actually between name and so earliest actually would be before that. So earliest. Let's see. I'll call this language definition. There are different times when depending when right in different languages. Right. So let's start with the first one. Language definition time. Language definition. Design time, right? So basically, what am I talking here? So, for example, integer. When I write int, a keyword, right, in a C language type, you know, C or C++, that's what I mean, right? I mean, it's like you can't redefine integer. Well, you can do macros, right? But still, you can't, right? So this would be like yeah, building functions, right? Yeah. So for example, yeah, yeah. But of course, that said, it can be redefined in a code in the case of Python, right? Right. So that of course is not, but not all language. Most languages would not let you do it. Yeah. Right. This Python is an exception, right? So because it's so loose, right? But yeah. So another example would be int, right? Int in C, right? Built-in data, right? You don't. I mean, unless you are using a macro, you can't redefine, right? You don't really redefine int, right? So, so yeah, so that's language definition. Okay, right? Then we have compilation time, right? Compile time, right? So for most languages, right? So when you compile the code, C++, well, Java for JVM, let's see, Go or Rust, or let's see, after that, compile language we know. Well, give me another language which compiled.
C++.
I said C++.
Oh, okay.
Something else. I was first, yeah. So
C.
C, yes, okay.
C sharp.
C sharp, yeah, sort of. It compiles to .NET usually. It compiles to intermediate, but yeah, combines bytecode. So we'll call it, yeah. Let's see what else. So Rust, Go, right?
PHP compile?
Which one? PHP is generally not compiled unless you work at Facebook. They do compile there, right? They have special, what's called hack. What do they call some really weird name? They basically were such heavy users of PHP at Facebook, right? That they had to make up their own PHP compiler, basically, right? Hello there, yeah.
Do they have React?
Well, React is for front end.
Oh.
Yeah, that's front end. Yeah, that's a JavaScript library. Yeah, but yeah, PHP is kind of weird. Like the PHP they use at Facebook is like this ultra, like special customized version of PHP, right?
Is Clojure compiled?
Well, okay, so Clojure is compiled actually when you compile because you compile the JVM, right?
Yes.
Compile bytecode. So yeah, technically it's compiled. Yeah. Of course, we also run it sort of in intermediate mode also, right? So, but yeah. So these codes are compiled, right? Common statistically, so statically typed language. So statically typed language, right? Bind to values, right? So, okay. Let's see. So we now, of course, we are going to get to runtime, right? Which we already saw. So what other times could we think? Well, what's in between? Runtime, right? Well, sometimes you have multiple modules, right? Like C++, right? There's also linking time, right? You have multiple modules, you link things. So technically, yeah, there's also link time. There's technically link time. Link time, right? So, yeah. Yeah, but of course now for example, let's see. Yeah. So this is, yeah, so that would be one way of doing it, right? So, right. So for example, yeah. This, declare static variable. Of course, static, right? I'm not talking about dynamic, right? Dynamic is a little bit different, right? Because you don't know, right? So, right. So linker. I guess you can say load time. How about load time? Load time, is that actually possible? Yeah. So, yeah, so, right, load memory, right? So this is kind of like runtime and load time sort of together, right? So let's see what the AI says about this. For example, yeah, right. So that's actually, yeah, that's true. Yeah. So good example. Thank you, AI. You define the function, but you're not actually using it, right? It's defined, right? The code runs, right? But technically, you're waiting to run it, right? It's bound, right? So, right, and of course runtime. That's what we saw, right? And this is a common, right? This is right on, right? So, for example, right? Yeah. No, that's not it. Example. For example, as when we run that the code, right? So, okay. So that's basically it. I mean, you can of course maybe think of something else between, right? I mean, you cannot go before it's, you can say, okay, if it's a language designer's head, maybe before language definition time, right? But that doesn't really count, right? And after runtime, you really can't go below that after that, right? So again, you could say, okay, so in a way, this link time and load time are sort of like, sort of in between. They're not as important maybe as compile time and runtime, right? So definition time, right? So that's basically it, right? So again, let's look at the static binding on dynamic binding, right? So static binding. Let's look at this, right? So static binding. Maybe let's do an example. Oh, is my code finished? Let's see if there's nothing interesting here. The code is really bad. So yeah, let's do this. All right. So binding times. pictures maybe for this. Or we can maybe look at some examples here. Let's see. So, well, we can't, of course, I cannot show, unless in compiling Python, I can show compile time, link time, load time, right? So I guess I could make some pictures, some examples, load time, right? So let's look at this here. So load time binding example, right, of a function, right? Right. So hello from my function, right? So that of course is right, and of course then I run it, right? Hello from my function, right? I bound it, and of course again. So my function. Yeah. So of course, so in this case of Jupyter, of course you have to be careful, right? Because if you are like using these interactive notebooks, the values it might not be bound. That is, the code is not run, it's not obviously not bound. Just because it's on a screen doesn't mean it's bound, right? So obviously in a regular program it would be bound. Yeah. So runtime binding, right? So right. So hello my function. So you say, okay, so you say it's like we loaded it, but really it's like you load it from maybe another module, for example, right? So, right. So, and again, runtime binding is simply binding into value of the runtime, right? So, right. So, yeah. So yeah. All right. So again, now, so static versus dynamic binding. All right, so what are we talking about here? Right, so static binding, or we call it early binding, happens before compilation, right? So C++ function overloading, for example, right? So let's look at the example, static early binding, right? Static binding, right? Yeah, so again, compile time, link time, that's early binding, right? So, right, on late binding obviously is late. Dynamic binding is, right, yeah. Let's see, do we have any examples of C++ binding things? I can't really run C++ code from a notebook. I could, I guess, example. Let's see if I can. Be interesting if we could. I mean, of course, I have to compile it, right? But I guess I'll just have an example, right? Example of binding in C++. Let's see if this. Let's see if I can do this with triple quotes. Yeah, CPP or CPP, right? Include IO stream, right? Of course, stupid example. I want some example here. All right. Now, of course, right? So that of course is statically bound, right? So integer, right, will have value 10 when you actually compile it, obviously, right? So, and of course int x, right? X is going to be bounded 10 at compile time, right? It doesn't mean it's a constant value, it's bounded, right? So, okay, so nothing too crazy, right? And now late binding example. Let's do a late binding example in Python. Late binding example in Python would be something, right? Well, yeah. This is kind of weird. It's a bad. I don't like this example, but let's roll with it, right? Yeah. So I'll do my. Well, let's take a look. So my name equals. Oh, yeah, I already have. Okay, yeah. It will work because this will work because already. Let's see. This works. No, it's not. Doesn't work. My name is not defined. I thought I did define somewhere. I guess I did not. My name. Oh, I did not. You see, AI thought I did, but I did not run the code. Right. So it's not defined. So I have to bind it, and now it should work. Is this a good style? No, it's not a good style to do this kind of stuff, but it works, right? It worked, right? But not a good style, right? By the way, note above is not a good style, right? But it's possible, right? So we had a global variable, right? Yeah, not a good practice, right? Try to avoid this type of code, right? Just because teacher shows something on a screen does not mean you should do it exactly like that, right? Yeah. So let's give you some bad examples, right? I mean, it's convenient, right? You work something, you just throw some variables. So why? coming from these functional languages. Why should you not? This is kind of bad practice. Because, why is this kind of bad? This type of function, right? Because, well, this function has no idea what heck it is, right? It has no way of controlling, right? It has no, I mean, it will print something. In this case, of course, it will work. But in general case, reasoning, it's very hard to reason of this type of code, right? Because it's my name, right? It's variable, right? It could be who knows what, right? And you can't really test this type of program. It's hard. I mean, you can test it, but it's really hard to test this type of program, right? So, so instead, what you should do is how you do it in Clojure. You pass in the variable in, right? Yeah. So even in Python lets you do whatever, right? But even then, you don't really want to do it, right? So maybe let's do another example of this Python, right, with classes. Let's see. So this example, let's do another example of Python late binding with two different classes. Then one of them will be assigned to a variable. Then instance of them, let's say like some simple class of class A, right? Something like this, right? Something really simple, right? Right? Very stupid, but let's roll with it again. Right, right, so we can say my class, right, and of course, again, of course, nothing is stopping you from using different legal letters for the names. But so now of course we can do, of course, print name, print, right? This will print A, and of course print B. This will be print B. So of course this will print B. So again, there's nothing, it's all things like so pretty self-explanatory, right? But again, just remember this is late binding. Right? So this will be late, yeah. Instance created on a class, right? So again, the thing is why this is again. So why is this sort of like why do we care? Because depending on language, right? If you only use one language all your life, right? So you'll be sort of set in your ways, right? But inevitably you'll come up with different language, and it has a slightly different way of doing things. Maybe it initializes later, maybe very early, right? So, okay. So this is basic idea of binding. Let me see what the official slides say about all of this. Right, so let's see slides, right? Yeah, abstraction, right? So name and thing with name. So again, simple, right? So scope is the textual region of the program in which the binding is active. This will do after the break. Let's not go into scope too much yet, right? So the complete set of bindings, right, is a referencing environment. Fancy name, right? That's what theory says, right? Referencing environment. But basically means okay, wherever it works, basically the area of your where the program, right, knows exactly where it is, basically, right? So binding time, language design time, I said so, right? Language implementation. So yeah, so design time, implementation time, yeah, it's kind of like runtime, right? Or program writing time. Programmers choose algorithms and names. This is like even I guess the author here, the professor here came up with another like when you write code that you choose the name, right? Yeah, I guess you could say that's when you bind the names in your head, basically, right? So runtime is again very broad concept, right? So we get startup time, module entry time, elaboration time, right? Procedure entry time, block entry time, right? So now, the later, so this is a general sort of like, is one way better or worse, right? So the later you bind, the more flexible you can do, right? Python, super flexible, right? However, Python is also super slow, right? So it's a cost, it's a trade-off. It's always a trade-off, right? Not always, I mean not always, but usually there's a pretty big trade-off, right? So early binding times, well, it's pretty much set in stone, but you of course in C++ and C and all these statically early bound languages are of course considered to be more efficient. Again, so why is that the case? Well, because the compiler can make optimizations, right? You can reason, okay, maybe you can arrange memory, do some things, some fancy, modern compilers are very fancy programs. They can do, if you know how to write an assembler or machine code, you would have no hope of beating modern compilers, basically, right? Maybe 20, 30 years ago, you could do your own assembly programming, right? Do you guys have an assembly course? You're lucky you didn't, right?
We did.
You did?
Well, it wasn't the whole course.
It was just a couple lectures,
I
right?
touched on it.
Yeah.
I touched on it.
Yeah, for which architecture did you do assembler? For ARM or no? For Intel, or it's like a fake assembly?
I think fake.
It was a fake, yeah. So not too bad, I guess, right?
It was from the NAND to Tetris.
Oh, okay, yeah, from that. So you had to kind of make your own architecture
Yes.
thing. Yeah, okay, all right. But yeah, so the takeaway from all of this is that compiled languages, right? Of course, they will tend to have early binding times, right? And of course, they will have better efficiency, right? So binding, the key things you should pay attention to when you're doing something. Okay, so when are the objects created, right? Because I mean, sometimes things like, okay, you look at this code, right? So is A actually ready? I mean, is at which point? Here we know it's runtime because we know Python pretty well, right? So, but it's possible this is actually bound, maybe earlier, right? So, and again, it could be also rebound, right? Of course, again, now we could also do shadow, right? So we'll talk about shadowing the scopes. So also, another key point we haven't talked yet is destruction of bindings, right? All right, so let's think about that. Maybe let's do this destruction of bindings, deletion of bindings, right? So deletion, or when the program ends, right? Naturally, when the program ends, well, hopefully there's no variables hanging around, right? But however, many languages have constructs for deleting bindings, right? You can do, in Python we have a delete keyword. Let's take a look, right? Doesn't work for everything, right? So let's see, let's try an example. Let's delete. Let's delete. Right, so first of all, this prints, right? Delete, not delay. Delete. Come on, delete. Yeah. Let's see what happens now. Of course, I'll do try. This will raise an error, of course, obviously, except name it, right? Let's take a look, right? So, again, seems to be obvious, but of course, so delete, right? Of course, which is of course a language bound. And delete is a keyword. You cannot reassign, right? So A, name error is not defined, right? So what happened to A here? Who knows in Python what happened here when I did delete A? What happened to the A? I mean, it was
Deallocated.
Yeah, it is deallocated. So when? Do you know when? Any idea when? Like right? It was so A is free, but okay. But what happened to this the data in this instance? When I created this one, right? So, and there's nobody else pointing to it. So what happens to this data inside? What happens to it? It goes to what?
It goes to garbage.
Yeah, garbage collection. Right. So what happens? There is sweeping algorithm. There's an algorithm. It's called timing for it, right? Maybe every half second, maybe I don't know, every 100 milliseconds, maybe every second, maybe only every 30 seconds. You can optimize. You can set this value depending on your, on your settings, basically, right? If you're doing some high performance computing, right, you maybe want to delete quicker, right? It depends, right? Really. So, and the famous, of course, C++ does not have this, right? C++ you deallocate and that's it, right? But here, right, yeah, so underneath the A, since nothing is pointing at some point, right? What that point is depends on Python implementation and version, right? Some languages, some languages, yeah, some language garbage collections, of course, language garbage collections, yeah. For some in some languages, you can set the sweep. Yeah. Let me see if I can remember. Yeah, GC module. There, I think there is GC module. You can say, okay, when do you want to, when you want to save the time, yeah. If I remember correctly, let's look at documentation. This is sort of side quest again, right? Documentation for GC. All right, let's take a look. It's like very rare you would want to do this, yeah. But you can enable, right? It's kind of like by default, right? But you can disable it, right? This means all the stuff is going to collect. You probably, I don't know why we want to do this in Python, right? Because of course it would be, well, maybe you, okay, let's think about when would you want to do this? When you have something really specific timings, and you don't want that, when you have some really expensive, heavy memory objects, cleaning those will take maybe, I don't know, like 100 milliseconds, maybe half a second, I don't know. Like, I don't know, 100 million values, and they're all very difficult objects, meaning complex objects, right? So what you do is you disable it, you do your performance thing, and then you enable garbage collector when you have time. I suppose it's possible. I've never done this on a production code because it's never, on Python, if you have those kind of problems, you generally don't write Python for those type of code. Okay, but it's possible, right? This will be another discussion for another day, basically. But yeah, it's something extra for you guys. So we are actually doing pretty good. Where's my garbage collector? Oh, there you go. Right. So this discussion for another day, another time. Okay. Right. All right. So that is enough for first part, and afterwards, let's take a break for 10 minutes. Yeah, and we will discuss the scope.
Right, I'm gonna have to leave this lesson 15 minutes early.
Okay, that's fine. Right. Let me see if I can do some.
Vai kompis paliks.
Viņiem mierīgi.
Nu, nē, viņš man... Viņš man...
Jau īstais, tas nav īstais.
Saka, kur man jābūt? Kur tik bija? Man ir jāiet.
Kriezums saprīt, tu dzīvi, ko es raugu.
Jā, ko es dzīvi.
These divas. Tad ņem 3-2, tas jāpasaka. Tā nauda bilbēs. Cik tie 3-2 paliekas? Tagad ir tāds periods.
Mums pilnīgi patīk. Pilnīgi nākam.
Es vienkārši klausās background mūzika.
Un jau arī tāds sagrus. Tas izdeja, ka viņi turās. Jā, jau, nav vairāk. Es neredzu. Monkeys, oh monkeys. Classic album. What do you
What?
Šodien es beigšu algoritmu kursu. Nē, beigšu AI kursu.
Kāpēc tu neesi iekšā? Vai tu taču no Rīgas esi? Taču no Rīgas studējām?
Recording? Oh, yeah, we are recording.
Nebija mūsu grafikā, bet viņam